Welcome back to another Kafka internals exercise. In this exercise, we'll be exploring consumer groups. Consumer groups are a vital aspect of Kafka that impacts how work can be parallelized over many application instances. So to get a better feel for this, we're going to be diving a little deeper into the consumer group protocol, seeing how it controls the behavior of a Kafka consumer group as consumers join and leave the group. Just as in the last exercise, there are a couple prerequisites that you should go through just to make sure your environment is set up for the exercise. The instructions on how to do so are contained in the instructions below the video, so make sure you walk through those, and then we can get started.
In part 1 of this exercise, we'll start up 3 consumer instances and assign them the same group ID. As June mentioned in the previous consumer group protocol module, setting a common group ID means that the 3 separate consumer instances will join the same consumer group. Another thing to note is that we'll configure the consumer instances to use the range partition assignment protocol. This just defines how the partitions are divvied up amongst the consumers that join the group. Once we start the consumer instances, we'll confirm that they join the consumer group and observe how partitions are actually assigned using the range protocol. I know that was a lot to keep track of, so let's get started. Let's bring up a terminal and use the Confluent CLI to confirm that the topics exist and are ready to use. We'll first log into Confluent Cloud, and note that we're using the save flag so that our credentials will be used for subsequent commands in this exercise. They'll remain active until you run the logout command. Now we can verify the exercise cluster and see if the topics exist. As you see here, the cluster and topics are present. And just a note, if you're not seeing either the cluster or the topics, then I recommend you check out the environment prep instructions in the write-up below before continuing. Alright, let's also confirm that the Java client configuration file that we mentioned earlier exists. It should contain the API key and secret that we need to access our cluster. Our file looks good. It contains the API key and secret, as well as the Bootstrap servers pointing to our cluster. Note that this same value will be specified in the Bootstrap server property of commands that we run during this exercise, so it might help to keep it handy. Now we can begin part 1 of the exercise. Let's start up our 3 consumer instances. We can use the Kafka console consumer tool as our Java consumer client. You'll want to bring up a new terminal or terminal tab as you create each consumer instance. We'll give each consumer a different client ID and make sure that they're all part of the same consumer group. Notice that they're subscribing to both the test 1 and test 2 topics, and we're also specifying the range assignment protocol as we mentioned earlier. You should now have 3 consumer instances running, each with a unique client ID assigned. Let's see how the partitions of the test 1 and test 2 topics were assigned to these instances. Going to another terminal window, we can confirm this using the Kafka consumer groups command. It appears that only 2 of the consumer instances were assigned partitions, while the 3rd consumer is idle. June covered this scaling limitation of the range partition assignment strategy in the consumer group protocol module. Basically, the limiting factor is the number of partitions for one of the subscribed copartition topics. In this case, we have 2 subscribed topics, each with 2 partitions, so only 2 of the consumer instances were assigned partitions. Let's stop these 3 instances and move on to section 2. In the second section of this exercise, we'll start 3 new consumer instances, but this time we'll configure the first 2 consumers to use either the sticky or cooperative sticky strategies, while instance 3 will only use the sticky strategy. After these instances are up and running, we'll see which of these protocols is used by the consumer group and observe how the partitions are assigned using the selected protocol. We'll start up consumers 1 and 2 with the sticky and cooperative sticky assignment strategies. And finally, we'll start up that 3rd consumer with just the sticky assignment strategy. With all 3 consumers up and running, let's see what partition assignment strategy is being used by the consumer group. After running the describe command on the consumer group, we see that the sticky strategy is being used. This is the result of an election that occurs when the consumer instances join the group. All of the strategies that are configured for each consumer instance are candidates. And in this case, the election was easy, since only the sticky strategy was configured for all 3 consumer instances. The primary situation where the selection process is required is when an application is updated to use a different partition assignment strategy. First, the new strategy is added to all consumer instances using a rolling upgrade process. Once this new strategy has been added to all consumer instances, a second rolling upgrade can be done where the prior strategy is removed from each consumer instance configuration. Let's check to see how partitions were assigned to the consumer instances by the sticky strategy. Describing the consumer group members shows that one instance was assigned 2 partitions, while the other 2 instances were assigned a single partition. This is how the sticky assignment strategy works. It effectively assigns partitions in a round-robin fashion, resulting in a more even distribution of partitions to all consumer instances in the group. With this strategy, as well as the round-robin and cooperative sticky strategies, scaling of the consumer group is limited by the sum of partitions from all subscribed topics. Let's now move on to part 3 of this exercise, where we'll start a 4th instance and confirm that the partition assignment is rebalanced. Start up a 4th consumer using the sticky assignment strategy. Recall that when a new instance starts, it will send a request to the group coordinator to join the group. In response, the group coordinator will notify existing members that a group rebalance is in progress. Each member will respond by also requesting to join the group. Partitions are then assigned to the updated group membership, and event consumption continues. Let's see how partitions were assigned to the 4 group members. Describing the consumer group, we see that it was successfully rebalanced, and each consumer instance is now assigned a single partition.
During this exercise, we observed the consumer group protocol in action and witnessed a number of pretty cool things. First and foremost, we saw how consumer group scaling is limited based on its partition assignment strategy. We saw how partition assignment strategy election operates, saw how partitions are assigned by the different available strategies, and finally, we saw how the consumer group rebalances when a member joins the group.
If you are running this exercise along with me, when you're done, you need to tear down the exercise environment by deleting the cluster. This will prevent it from unnecessarily accruing cost and exhausting your promotional credit. Let's walk through that teardown process for this exercise together. First, list the clusters in the Confluent Cloud environment. For this exercise environment, you should only see 1 cluster. Now we can delete it. And finally, as a sanity check, we'll confirm that the cluster no longer exists. No clusters are listed, so the environment teardown is complete.
As I mentioned at the beginning of this exercise, the consumer group protocol is a pretty important part of Kafka as a whole, opening up the realm of parallelization and optimized stream processing. I hope you'll join me in the next exercises as we continue to dive deeper into Kafka internals. See you there!